contain straight line x by 2 is equal to y by 3 equal to z by 4 and perpendicular to the plane containing the straight lines x by 2 is equal to y by 4 equal to z by 2 and x by 4 equal to y by 2 and equal to z by 4 is, we have to find the equation of the plane. So let us find the equation which is perpendicular to these given straight lines, that is 2, 4, 2 and 4, 2, 3. So what would be the equation? I'll be writing it I cap and below that it will be 2, 4, 2 and 4, 2, 3. So let's find out. It would be equal to I cap into 12 minus 4 minus j cap into 8 minus 12 plus k cap into 4 minus 16. So the equation would be 8 I cap plus 4 j cap minus 12 k cap. So this is the equation. Now what are the points? So the points would be 8, 4, minus of 12. Now we have to find the equation which is normal to this plane. So it would be normal of plane. So that would be, again I'm writing I cap, j cap, k cap. So that would be 8, 4 minus 12 and this thing 2, 3 and 4. 2, 3 and 4. So let's find out the equation. So that would be equal to I cap into 16 minus plus 12 3s are 36 minus j cap 8 4s are 32 plus 12 2s are 24 plus k cap into minus 24 2s are 8 minus 8 3s are 24. So let's find out. There would be change here. K cap, the here it would be 8 3s are 24 minus 4 3s are 12. Now let's calculate. So it would be equal 52 I cap minus 66 j cap plus 12 k cap. So this is basically the equation of the normal of the plane. Now what would be the equation of the plane? Let's find out. So equation of required plane, that would be this plane, that is 52 I cap minus 66 j cap plus 12 k cap. It will be multiplied with x I cap minus y j cap plus z k cap equal to 0. So this would be the equation of the required plane. So let's find out. So that would be equal to 52x minus, it would be plus here, so it would be 52x minus 66y plus 12z is equal to 0. So we can write it as, we can divide it by 2, so we will get 26x plus 33y plus 6z is equal to 0. So this is the required equation of the plane. I hope it is clear. Thank you.
हाय गाइस, हमारा क्वेश्चन है अ प्लेन passes through 1 minus 2 1 and is perpendicular to two planes 2x minus 2y plus z is equals to 0 and x minus y plus 2z is equals to 4. Then the distance of the plane from the point 1 to 2 is. तो ये कहा है एक प्लेन है जो इस पॉइंट से पास कर रहा है और इन दोनों प्लेन्स के परपेंडिकुलर है, तो उसका उस प्लेन का और इस पॉइंट का कितना डिस्टेंस होगा वो निकालो. ऑप्शन हमें दे रखे हैं 0 1 √2 2 √2. ठीक है, तो चलिए सॉल्व करते हैं. सॉल्यूशन, तो मेरा इक्वेशन ऑफ प्लेन पासिंग थ्रू पॉइंट क्या दे रखा है मुझे 1 minus 2 1, तो मेरा फॉर्मूला क्या होता है, फॉर्मूला होता है a इंटू एक्स माइनस एक्स वन प्लस b इंटू वाई माइनस वाई वन प्लस c इंटू जेड माइनस जेड वन इज इक्वल्स टू 0। तो एक्स वन वाई वन जेड वन की वैल्यू मुझे दे रखी है, मैं पुट कर देती हूँ। ये आ जाएगा a इंटू एक्स माइनस वन प्लस b इंटू वाई प्लस टू प्लस c इंटू जेड माइनस वन इज इक्वल्स टू 0। इसको कह दो इक्वेशन नंबर 1। अब ये कहा है कि वन जो प्लेन है ये परपेंडिकुलर है तुम्हारा टू 2x माइनस 2y प्लस जेड इज इक्वल्स टू 0। तो यहाँ से मैं लिख सकती हूँ कि परपेंडिकुलर होने की कंडीशन क्या होती है, ये होता है कि 2a माइनस 2b प्लस c जो होगा वो 0 के बराबर होगा। इसको कह दो इक्वेशन नंबर 2। और ये भी दे रखा है कि मेरा वन जो है वो एक और प्लेन के परपेंडिकुलर है, x माइनस वाई प्लस 2z इज इक्वल्स टू 4। तो यहाँ पे भी परपेंडिकुलर होने की कंडीशन ट्रू कराओ तो ये होगा a माइनस b प्लस 2c इज इक्वल्स टू 0। ये इक्वेशन नंबर 3 है। अब क्या करो, सॉल्विंग 2 एंड 3 यूजिंग क्रॉस मल्टीप्लिकेशन। तो ये मेरा आ जाएगा a अपॉन माइनस 4 प्लस 1 इज इक्वल्स टू b अपॉन माइनस 1 प्लस 4 सॉरी इट विल बी प्लस 1 माइनस 4 इज इक्वल्स टू c अपॉन माइनस 2 प्लस 2। ठीक है, तो ये कितना आ जाएगा, ये आ जाएगा a अपॉन माइनस 3 इज इक्वल्स टू b अपॉन माइनस 3 इज इक्वल्स टू c अपॉन 0। तो इस पूरी इक्वेशन को माइनस 3 से मल्टीप्लाई कर दो तो ये आ जाएगा a बाय 1 इज इक्वल्स टू b बाय 1 इज इक्वल्स टू c बाय 0। लेट अस से ये किसी k के बराबर है। तो मुझे मिल गया कि a जो है वो k है, b जो है वो k है, c 0 है। अब तुम इसको इक्वेशन नंबर 1 में पुट कर दो, पुट इन 1। तो ये तुम्हें क्या मिल जाएगा, ये मिल जाएगा कि मेरा k टाइम्स x माइनस 1 प्लस k टाइम्स y प्लस 2 प्लस 0 इज इक्वल्स टू 0। तो पूरी इक्वेशन को k से डिवाइड कर दो तो ये मिल जाएगा x प्लस k प्लस वाई माइनस सॉरी एक्स प्लस वाई प्लस 2 माइनस 1 1। तो x प्लस वाई प्लस 1 इज इक्वल्स टू 0। ये इक्वेशन ऑफ द प्लेन आ गया। अब मुझे इस प्लेन का इस पॉइंट से डिस्टेंस निकालना है और मेरे पास डिस्टेंस बिटवीन द पॉइंट एंड द प्लेन का फॉर्मूला होता है, तो मैं वो फॉर्मूला यूज़ करती हूँ। तो मुझे मिल जाएगा डिस्टेंस ऑफ 1 2 2 फ्रॉम, इस प्लेन को मैं इक्वेशन नंबर 4 कह देती हूँ। तो ये मेरा बराबर हो जाएगा मॉडुलस ऑफ, फॉर्मूला क्या होता है कि इक्वेशन ऑफ प्लेन में तुम ये पॉइंट सेटिस्फाई करवा दो तो ये हो जाएगा 1 प्लस 1 प्लस 2 प्लस 1 होल डिवाइडेड बाय अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर प्लस c स्क्वायर। तो ये हो जाएगा 1 प्लस 1। तो ये आ जाएगा मेरे पास 4 डिवाइडेड बाय अंडर रूट 2 और 4 डिवाइडेड बाय अंडर रूट 2 कितना होता है, ये होता है 2 अंडर रूट 2। तो मुझे यहाँ से मिल जाएगा कि ये बराबर है 2 अंडर रूट 2 यूनिट्स के। तो देखते हैं ये ऑप्शन में है या नहीं है। तो ये ऑप्शन नंबर 4 है विच इज योर करेक्ट आंसर। थैंक यू।
The question is, let L be a straight line passing through the origin. Suppose that all the points on L are at the constant distance from two planes, that is P1 is x plus 2y minus z plus 1 is equal to 0 and P2 is 2x minus y plus z minus 1 is equals to 0. Now let M be the locus of feet of perpendicular drawn from the points on L to the plane P1. Which of the following points lie on M? Here we have 4 options, option A, option B, option C and option D, and we have to find which one of the option is a correct answer. Now here in this question we have given that two planes. First is P1 and here P1 is x plus 2y minus z plus 1 is equals to 0. Next we have P2 is equals to 2x minus y plus z minus 1 is equals to 0. Now next, the line L will be parallel to the line of intersection of plane P1 and P2. So now next, let ABC are be the direction ratios of the line L. So from here we have that A plus 2B minus C plus 1 is equals to 0. Let me write it correct here. It will be, here we have A plus 2B minus C is equals to 0, and next 2a minus b plus c is equals to 0. So from here, after solving these two equations, here we have value of a, and that is 1, value of b is minus 3, and value of c is minus of 5 after solving these two equations. So now, hence the equation of line L, is equals to, that is x minus 0 by 1 is equals to y minus 0 by minus 3 is equals to z minus 0 by minus of 5. Now as it passes through the origin, passes through origin. So now next, the foot of perpendicular from the origin to the plane P1 is equals to, here we have minus 1 by 6, comma, minus 1 by 3, comma, 1 by 6. So now the equation of a plane, the equation of a projection of a line, projection of the line L on our plane P1 is at point M, as we have x plus 1 by 6 divided by 1 is equals to y plus 1 by 3 divided by minus 3 is equals to z minus 1 by 6 divided by minus of 5. Now put this value as equals to c. Now here, for the options given, only point minus 1 comma 6 comma minus 1 by 3 comma 1 by 6 and second point, and the point that is 0 comma minus 5 by 6 comma minus 2 by 3 satisfy the equation of a line of the projection M. So from here we can say that these two equations are our final answer. So now these 2 points are our final answer. So if we look at our option, so here option number A and option number B is our correct answer. Thank you.
Today our question is, if the straight lines x minus 1 upon 2, y plus 1 upon k, z upon 2 and z plus 1 upon 5, y plus 1 upon 2, z upon k are coplanar, then the plane containing these two lines are. So first of all, to find the equation of plane, we should know the value of k, right? So to find the value of k, we know that these two lines are coplanar. Coplanar means they lie in the same plane. So we have a formula of determinant that says if three lines are coplanar, then their the determinant will be 0, right? So if we connect, like let's say in this first equation, we have in line 1, we have our points as 1, minus 1 and 0, and in L2 we have our points as 1, minus 1 and 0. So since the two lines lie on the plane and we have point on each line, so if we connect these 2 points, then we can get the equation of the third line also. So how we gonna do this? We will just subtract all the coordinates. From here we will have minus 1 will be 2, minus 1 plus 1 will be 0, and 0 minus 0 will be this, right? So from here we can say that our points for the third line will be these. This will be the direction ratios, the direction ratios of the third line will be x2 minus x1, y2 minus y1 and z2 minus z1. So we have just put that formula. Now we know that in these lines 2, k, 2 are the direction ratios of first line 2, k, 2, and the direction ratios of the second line are 5, 2, k, and for the third line we have find out the direction ratios as 2, 0, 0, right? So we will put them into the formula and then we will get 2, k, 2, 5, 2, k, 2, 0, 0, right? And this should be 0 if the three lines are coplanar, right? So then we will find the value of k as 2 into 0 minus 0, 0, minus k into 0 minus 2k. So minus 2k plus 2 into 0 minus 4 is equals to 0. Right? Then we will have plus 2k square minus 8 is equals to 0 and k square will be equals to 4. And then we will have k is equals to plus minus 2. Right? Now for k is equals to 2, for k is equals to 2, our equation of line will become x minus 1 upon 2. X minus 1 upon 2 is equals to y plus 1 upon k, that is 2, and z upon 2. Right? This will be our line 1. And line 2 will now become x plus 1 upon 5 is equals to y plus 1 upon 2 is equal to z upon 2. This is what our second line. Right? Now we can see that the two lines are same for y plus 1 upon 2 and z upon 2. Right? This is the common part in both the lines. So from here we can say that y plus 1 upon 2 is equal to z upon 2, and so y plus 1 is equals to z is the first equation of the plane. Right? So our y minus z plus 1, our option 3 is correct. Now we will check for the another two also, because we have one more value of k, that is minus 2. So for k is equals to minus 2, for k is equals to minus 2, our line's equation will become x minus 1 upon 2, y plus 1 upon minus 2, and z is equals to 2. This will be our line 1, and the second line will become x plus 1 upon 5 is equals to y plus 1 upon 2 is equals to z upon minus 2. Right? So from here, now to have the equation of second plane, we should have the normal first. Okay, from these two lines we will have the normal equation. Since the direction ratios of the first line is 2, minus 2 and 2, and the second line direction ratios are 5, 2 and minus 2. Right? So easily find out the equation of normal by taking the cross product of these two vectors. Then that will give us a, b and c. Right? So a upon leaving the first two coordinates will give us minus 2 into minus 2 will give us 4, minus 2 into 2, that is 4. Right? So 4 minus 4 is 0. Then b upon it will be 10 plus 4, so 14, and c upon it will be 2 into 2, 2 minus 2 and 5, 2. Right? So 2 into 2 4, minus 5 into minus 2 is minus 10. So 4 minus minus 10 is 4 plus 10, that is 4c upon 14. So direction ratios of the normal are a upon 0, b upon 14 and c upon. So we will have our equation of plane as r dot n is equals to a dot n. Right? Here our normal vector is 0, 14 j cap and 14 k cap, and r is what? X, y, z. So x into 0 plus y into 14 plus z into 14. And here our passing point is 1, minus 1 and 0. The plane is passing to this point. So we will have 1, minus 1 and 0 k cap into the normal vector, that is 0i, 14j and 14k. 0i, 14j and 14k. So then you have 14y plus 14z is equals to minus 14 plus 0. So 14 and 14 will cancel out and we will left with 1 y plus z is equals to minus 1 only. So we can say that option 2 is also correct. Thank you.
Hello everyone, today we are going to discuss one more question. The question says that let P be the point in the first octane whose image Q in the plane x plus y equals to 3, that is the line segment PQ is perpendicular to the plane x plus y equals to 3 and the midpoint of PQ lies in the plane x plus y equals to 3 lies on the z axis. Let the distance of P from the x axis be 5. R be the image of P in the xy plane, then the length of PR is. So let us take this one is our plane here. This one is given plane here, and this point is here P and this point is here Q. So this line is PQ here. This line is here PQ passing through this plane here. So equation of line can be written as here x minus 0 divided by 1 here, which is equals to y minus 0 divided by 1. Since here x plus y equals to 3, so direction cosine ratios are 1, 1 and 0. Z minus 0 divided by 0 here. Let us take this point is equals to here. If we take any point here, so where q is equals to 0, 0, 0 here. So equation of line x minus 0, y minus 0 and z minus 0, and direction ratios are 1, 1 and 0 here. So here we can write it as, since this one equals to 3 here, so we can write it as here this one equals to 3. So this one is implying x equals to 3 here, y equals to 3 here, and z equals to 0 here. Z equals to 0 here. So as here given that d is equals to distance from x-axis be 5 here, so distance from x-axis is equals to 5 here. So distance can be written as here d is equals to here, d is equals to distance from x-axis. So here only use y and z coordinates, so distance can be written as here y square plus z square. We have to take distance from x-axis, which is equals to here given that 5. So y is equals to 3 and z equals to 0 here. So 3 square plus 0 square is equals to here, from the z-axis, here given that lies on the z-axis. So let us take the point coordinate of z equals to a here. So this one equals to a here, z-axis, and y coordinates remain same and distance from the x-axis. So we can write it as here distance equals to y square plus z square equals to 5 here. So z square plus a square is equals to 5 here. Squaring both sides, we can write it as here this one equals to 3 square plus a square is equals to 25 here, or we can write it as here a square is equals to 25 minus 9, which is equals to 16. So our distance a is equals to here 4. So a equals to 4 here. Now as we know that if we take distance from z-axis, so this one is 4 above from z-axis and 4 below from z-axis. So total distance equals to here 4 plus 4. So 4 plus 4 equals to here 4 plus 4 is equals to 8 here. So here our final answer equals to 8 here. So length of PR, because as we can see here distance 4 is above from z-axis and from 4 below from. So total distance is equals to 4 remain. 8 here. So length of PR equals to 8 here. I hope you understand the explanation. Thanks for watching.